All right, good morning. This is the short course Introduction to Perl, presented by the Texas A&M High Performance Research Computing Center. We are, let me see how many people we have. Okay. All right. Yeah, I was just waiting to see if we were going to get some more people in here. And I will go ahead and get started now. Those of you who are Texas A&M University members, you should be able to use your net ID. Those people coming in from Access, if you should, when you registered, you should have presented your Access ID. And for those of you who have everything set up, we have given you the connection details so that you can get logged in to our system. And I will be going over that shortly. To start off with, if you look at the HPRC homepage under events courses, this is where we have the introduction to Perl. And then if you click on the view details, it will take you to the class homepage. And under course materials, there's going to be some instructions for how to connect to the system, depending upon what credentials you're using. There's going to be some slides that I'm going to be using for the presentation. And also there's a GitHub with the class material, which you can access at any time, whether or not you have an account with our system. So let me go ahead and show you the connection details. Okay, let me see if I can zoom this. All right. So what we're going to be doing to go over the material for this class is we're going to be using a Jupyter notebook that was created primarily for running Python, but we can also hack it to use some Perl code. So you need to be able to log in or to have a browser where you can connect to the portal. If you're on campus, you will be able to connect via login to a terminal. But since we're using Jupyter Notebook, then that will be hosted on the cluster itself, the faster cluster, or ACES, if you're coming in that way. So you will still need to be able to have to connect through the portal. So if you are a TAMU member with an net ID, then what you will need to do is to connect through portal-faster.hprc.tamu.edu. So let me demonstrate that real quick. Okay, so I've already logged in, and so if you have not yet logged in through CAS to any system, then you will be presented with the single SSO login, or the CAS CAS login, where you give your net ID and password. And then eventually, once you authenticated, then you will come to this landing page here. This is the portal for TAMU users. It's going to look the same for Access users. And the first thing that we're going to do is we're going to open up a shell access, but I need to go over. Nope. Okay. Sorry about that. Trying to figure out how to, okay. So back here, if you are coming in through Access, which is formerly called Exceed, you should have already created your Access ID, and when you registered for the class, given us your Access ID. We've worked with a few other people to get you set up. And So then what you'll do is you'll go to portal-faster-access, and then you open the link. And then here, what you're going to have to do is you're going to have to choose the Access CIXC ID. You're going to log in here, and then you're going to present your login name and password. Okay, and I'm not going to be using that for demonstration. I'm going to be using the TAMU, but basically you're going to end up in the same place. All right. If you do not have an HPRC account, either through TAMU or through Access, then there is the option to go ahead and use Google Colab. You won't be able to do every single exercise, but you should be able to do many of them. You'll be able to go through the Jupyter Notebook and see a lot of the exercises, work on them, get them running. It's just you won't be able to do a couple of the things that require access to faster or to ACES. Okay, so the first thing that we do once we've connected to the portal is we're going to go to the get shell access. So what I do up here under clusters, I'm going to choose faster shell access. Now on HPRC, if you are a TAMU member, you can also do similar things with the Terra and Grace clusters. And a lot of the software is going to run on both Grace and faster. There may be some that is still installed on Terra because we previously taught this class on that. But for today's purposes, we're only going to be working on faster. Okay, and so now I put in my password and I have to do the duo authentication. And so now I've logged in. So the first thing that I want to do once I've gotten into the shell is I need to go to my Scratch directory. So I CD to Scratch. Okay, so now I'm in /scratch/user and then my login name. And let me go ahead and I'm going to remove that because I'm going to demonstrate to you how to copy it. So you may have files here in your Scratch directory, that's fine. But the first thing that you're going to do once you've gotten to your Scratch directory is to clone the GitHub. So you're going to copy this this command here, git clone, and then this URL. And what I can do is, let me see. Okay, I can post this in the chat. Okay, so those are the commands that we're going to be running. So coming back to here, I'm going to do a git clone. So it's very small repo. And so I go to the Perl directory, and you can see I have a few sample files, but the main one that we're going to be working on today is the Python notebook, or the Jupyter notebook. So you should be able to do the same commands if you are running through Access. And I will let you go ahead and get started on that. And please raise your hand. Let us know if anybody is having trouble connecting and getting into the shell to run these commands. What I'm going to do now, while we're waiting on the feedback for that, is I'm going to scroll down here to the instructions for Google Colab. If you do not have an account with HPRC, you can go to the Google Colab, colab.research.google.com. And if we go here, all right. So now it's going to ask me to create a Jupyter notebook. I can go from if something I have saved on my Google Drive, but what the easiest thing that we can do is just to go to the GitHub repo where the files are located. So it's KJ Tamu, Keith Jackson, Texas A&M University /Perl. And you hit enter. Okay, so there's a repository under that. And there you have the Python notebook here. And so if I click this, this is going to launch the Python notebook for me. And this should work very similar to the portal version. There may be some slight differences in terms of the look and feel as far as the menus and what you see on the side here. But for those of you who do not have HPRC access, this is what you'll need to do. And you can just ignore the rest of the instructions for accessing through the cluster. Okay, so now that we have copied these files over, we're good on that. So the next thing we need to do is go back to the portal page on the dashboard. Up here at the top, we have interactive apps, and we're going to use that. Let me check. Okay, has anybody had any problems connecting? Please let us know. Okay. So the next thing we're going to do is we're going to open up the Jupyter notebook. We're going to click on that. Okay. I'm going to leave everything as is here. Anaconda environment, Anaconda 3, 2021-11. That shouldn't matter because we're not doing anything that's going to require extra Python libraries. But the one thing that we do need to change is the number of hours. Since this class is 2.5 hours long, I'm going to put 3 hours here. 1 core, 3 GB of memory is fine. It doesn't have to be even that much. And we're only going to be using CPUs. And we don't need to enter anything into these fields here. So then you click launch. So what this does is this is submitted a job to the queue, and we're going to have to wait for this to get ready. Once it starts running, it takes about a minute or so before you're able to actually connect because it takes that much time to do setup. So I have 1 node, 1 core, a very simple job. And okay, so all right. So this on the this connection thing PDF that gives you instructions on how to set up the Jupyter notebook. And then once it starts, what we're going to do, refresh. Oh, it's still setting up. Okay, so now once you you get a host name, and then you get this symbol with the little eye icon, it tells you can connect to the Jupyter. And I click that, and this will open up a new tab. All right, and so what this first does, the Jupyter notebook interface, it will load your Scratch directory. So I have a few directories here that exist. Those are created by the portal system itself, but we have this Perl directory here. Now, if you have a whole bunch of directories here, you may have to scroll down to find Perl. And we click on that. And the file that we're interested in is this, the Jupyter notebook. So I click on that. And this will launch the notebook. And it will take a few minutes to get loaded. Okay, it's telling me I have to wait. Okay, So it will take you a few minutes. Okay, so once you get here, then we're ready to get started. Let me go back here. The last thing that I have on these instructions is to restart and clear the output. I believe I did that before I saved it, the last version, but just to be sure, you can say restart under kernel, restart and clear output. And I think that it's slightly different on the GitHub. I don't recall exactly. It's the same idea, but it may have slightly different wording because it looks like that had a different version. Okay, so once we've opened up this notebook, then we will be able to go through the material here. These are clickable links. And once you get down to a code piece like this, what I can do is I can click run, and that will execute the command inside there. And here I'm issuing a bash command, and that inside the bash command, I'm invoking Perl to execute something. Okay, and the rest of it is basically formatted text with clickable links and so forth, and it has a lot of the same instructions. So if you're already here, then you've already done these instructions, so that this is a little redundant right here. Okay, so before we get into that, I will give you time to get started on that. And okay, so anytime that you have questions that pertaining to Perl or anything else with our clusters, you can always send us email. The best way to get help with a technical problem is to send email to help@hbrc.tamu.edu. It goes to the whole group, and then we can find the best people to handle your problem. You can also call us. If you're on campus, you can come by to Henderson or to Blocker. When you do send us a message to ask for help, please specify which cluster you're working on. Today we're working on Faster, but you could be working on Grace or Terra. If you can give us your net ID or your login name, that's very helpful. If you're running jobs on the batch system, if you can record the job IDs which have any particular issue, your directories, what applications and what modules you've loaded, the versions of everything. And if you get error messages, if you can copy and paste those are very good. And so anytime that we have an issue with a Perl program, it's often sent to me, so I can help you with that, help you diagnose, debug any problems and get things working. This is the page that we started on at the beginning of the class. These are the instructions for connecting to the portal. So this is redundant. We've already got that. And then, okay, so the last is acknowledgements. The funding for the cluster is thanks in part to NSF grants and the teaching system that all of the short courses and so forth. We have assistance through CC Star Suiter. So we wanted to not acknowledge them as well. Okay, so let's go back to the. We're gonna cover a number of topics here today. Some very basics just to get you started, and then I will give you pointers to where to find more information on how to learn additional, more advanced topics in Perl. Normally, when you want to run a program, you're just going to type a Perl program. You can type Perl and then the name of the file. So if I have sum.pl, I can look at that. And that's just a shell program. It has a print statement at the beginning. It has the shebang, the $, exclamation, and then where you can find the Perl. This putting the hard coding the actual path to Perl, that's not always a good thing. In this case, I'm just using the default Perl, which is installed on the system. But on our clusters, we also have a module system, the LMOD system. And so you may need to load certain versions of Perl. So if I say module spider Perl, and the LMOD command spider, basically it scans through the list of the installed software, looking for things that match this. So we have a number of Perl versions, and if you want to load one of those, you can use the module system for that. And then if I do a lowercase Perl, I'm going to get quite a lot more. There's bio Perl, and yeah, on our other clusters, we also have some specific packages of Perl which have a lot of libraries that our users need. And so if you're on Grace or Terra, you can also do the same command, and that will give you a longer list of the possible modules that you can use. But for this class, we're just going to be using the user bin Perl, which is the pre-installed version of Perl, and this is going to be 526. Okay, so we have sum.pl, and if I want to run it, I just type Perl sum.pl, and so that executes that command. Since it is a shell script, I could do this to execute it itself without having to call it, but I have not set the execute bit on this. So if you've created a .pl file and you want to be able to run it itself, make sure that the first line has the correct path. Either you can have user bin Perl, or you can do like env Perl, something like that. Then as long as you have set it to executable, then you can run it. Okay, so you can either specify the interpreter, or you can make it executable, and then it will go by the first line in that file. Okay, so we've already done this. This is what I just did. Now, here's an example of if I'm on the logged in, and forgive me if this doesn't paste well. Okay, so that did paste well. All right, so basically one of the things you can do with Perl with a lot of other Unix commands is you can do -e, and then you give it a code segment, and then I put it inside of single quotes because I have a lot of characters here which would be interpreted by the shell, so I don't want those to be expanded as wildcards or special characters. And so then I basically have just a simple statement in there. It executes it, it prints out the value, and so I don't even have to create a file in order to run that. So if you have, for example, if you have a bash script and you needed something that only that Perl could do easily, that bash didn't, for example, have the floating point operators, you could call Perl. You could also call other programming languages as well. Some of them will allow you to do this sort of thing. Okay, so as I demonstrated earlier, if you have a code segment here, the Jupyter notebook is divided into cells, and each one, as you click on them, it's going to highlight it. And if you've highlighted the one that has a command inside of it in this grayed out box, then you can do run, and it will execute the command within here. So this, since it's a bash command, basically what it does is it spawns off a bash shell, executes this, and then gives you back the answer here underneath. So this is basically the same thing that I did over here, but within the Jupyter notebook. Another thing that I like to do, if I'm working on a Perl program and I want to test some little bit of code and I want to make sure that I understand the specific syntax and what what that's going to give me inside my larger program, instead of running a big program which may not be ready for execution, I can just take a snippet of code and I can do an eval. So eval Perl, and the eval command, that's going to feed whatever I type in up until I hit Control D to the interpreter. So I could have eval bash or eval awk or something like that. So here, what I've done is I've created a list of 3 strings, and we'll get into the details of that soon. And then I have 3 different print statements, and they all have slightly different syntax. And I'm trying to figure out in my larger program, what is the type of answer that I want to get? Well, the first one, it puts them all together with no spaces. That may be what I want to do, but usually not. The second one, it treats it as a scalar number. So instead of giving me any of the values of the list, it just tells me the number of items in my list. Okay, I may want that, but probably not. The most likely case if I'm trying to print out a list is I want to print them out and I want to have some sort of separation between them. So in this case here, I put everything in quotes with the backslash. So then I get the list and each item is separated by space. So I go back to my larger program that I'm working on, and then I see, okay, this is the syntax that I want to use within my code. So that is another thing that you can do to run a Perl program. And then I did that by changing to the other tab to run it within the interactive shell, but you can also run it here since this is bash, but it's kind of a moot point because it's it's very simple. I could have just put this within the cell itself because I can run Perl here. Now there's a number of different utilities that you can run, especially if you're learning Perl and you're wanting to get familiar with the return value from different calls. Specifically, if you're testing, you make a call to a subroutine, and you say, okay, what type of values do I get back from this, and how do I evaluate it? So you can experiment with different syntax. Perl console, I had that installed on some of our older clusters. We're not going to be using that today. That is no longer maintained, but it is available from CPAN if you are familiar enough with that in order to download it to your own system. I really like the interface that Perl console gives you, but unfortunately it's not installed on our newer systems, and it's not easy to install. So what I'm going to use today, there's 2 programs called one's called Perl I, and this is available on GitHub, and there's another one which is a very simple program, which is just 3 lines, and it depends upon the program called RLWrap. If you have that installed on your system, basically if you do something like this, then every time you type, it's going to give you feedback on what you're running. Now I've installed Perl I and IPS on Faster. It's going to be under /scratch/training Perl capital P bin and then the name of the file. So if I go here, less scratch training Perl bin. Okay, so I have those 2 programs here. I'll start with Perl I. Okay, so I create the array and put it into X, and then as we showed before, I can do print X like that. And like I showed you before, if you put it in a certain context, it's just going to give you back the size. Now, one quirky thing about Perl I is it doesn't show you the prompt until you hit space when you are logged in through the portal on this, the shell. If you are directly connected, say through MOBA Xterm, or you have if you're connecting from a Linux or OS 10 system, if you connect through a regular SSH, then this shows up. But for whatever reason, on the portal shell, it's not showing that. But you can just hit space and then it will show you the prompts. Okay, so that's Perl I. And then there's IPS, Scratch Training Perl Bin IPS. And this gives you the same thing. Okay, and now notice that they have slightly different feedbacks. So Perl I, if I create an array, it's going to give me back all the items in that array. And then under the IPS, what it's going to give me back is the number 3. So this is the list, and this is the scalar, which is just the count. Okay, and we'll learn how in Perl there's going to be it treats lists and scalars slightly differently. So each of them have their own nuances as far as what feedback they give you. Okay, so let's go back to the notebook. Now, if you need to get information on how to do certain things in Perl, you want to find more information on a particular function or something like that. Well, if you just do man Perl to get the manual, then what this is on Unix is it's going to give you basically a table of contents. Like these are all of the different types of other manual pages that you can find. One of the things you can do is when you can look at the man page for Perl run, that will tell you like you can use the -E to execute a statement or things like that, and how to specify, you know, your file and things like that. Now let's see, here's one. Let's say you're wanting to learn object-oriented programming in Perl. That's something that I'm going to slightly touch on at the end of this class, but we won't have time to go over it. But let's say you're interested in learning that. So then I do man Perl OOTUT, and then this has the page for that. There's also, if you want to know all the built-in functions, Perl func. Okay, so then we start going into all the different, like, okay, ABS gives the absolute value of its argument. Okay, and so this is a very long man page. When I was first learning Perl, I was constantly scanning through this, and I didn't realize that it's very simple. Instead of going through that whole man page, I can just do Perl doc -F, which is Perl documentation for a function, and then you give it the name of the function, and then it jumps to that particular place in the Perl func manual page. And here it gives you all the different formats that you can use for arguments to call the sort function. It gives you some examples. It describes, you know, what each of the different versions do. Now, all of that is online, but it's much nicer if you go to perldoc.perl.org. So perl.org is the official Perl website, and under here we have perldoc. And so all of those pages that you saw before are listed here. So for example, the object-oriented tutorial is here. Okay, so if I wanted to, I can go through and look at it here online. It's a little bit nicer to have it formatted, and then you'll have it will mention something and you can click it, hyperlinks. So this is a really nice reference website to use to get information as you're learning, or even if you've programmed it for a while, if you want to do something you haven't tried before, there's the tutorials, there's reference manual. This will show you how, the details of the syntax, how to do different data structures, operators, things like that. And we'll go over those soon. And these are the most important ones to work with. You have operators, functions, variables, modules, utilities. And so we will be going over those as we go through the class. All right. So let's start off with the language itself. On the Jupyter notebook, in order to run Perl, I have the Perl commands here, but the first line is just going to be %% Perl. And so what that tells the Jupyter notebook is that all of the following is going to be interpreted through the Perl program. So let's start with this. I'll go ahead and run it. In Perl, the variables are going to have prefixes indicating that the $ means this is a scalar number. We've seen before the @ symbol, that means it's a list, and there's a few other types. And all of the statements are separated by semicolons. And anytime you have a loop or an if statement or something like that, you're going to have a code block, which is surrounded by braces. The # is for comments. And we'll go over different ways to do quoting and so forth. It has the printf function borrowed from the C and C++ language. So this program starts with 1, goes up to the maximum number, and I can change this here and run it. And it's going to do that number squared plus 1. Okay, so you can play around with this program. You can make changes to it. You can modify this from +1 to -1, and then you just run it again. Okay, so this is just an overview of how statements are constructed in Perl. It's very similar to, it's kind of a cross between C programming, C, C++, and shell programming, normal Linux shell program, which is, C shell, bash, things like that. And it borrows some from each of those. So when I refer to a variable in Perl, except for file handles, which we'll get to that when we get to IO, the names in Perl, they always have to start with the letter, and it's the usual rules for how you name a variable. No dashes, you have to use underscores, letters and numbers. And it is case sensitive, so if uppercase or lowercase, those are going to be interpreted as different variables. The types that we work with normally are scalars, which start with a $, lists, and which I'll also call arrays. It's the same concept. Those are @ symbol, and then the % for a hash table. So scalars can include integers, floating points, strings, binary data, or a pointer. It's not strongly typed, so if I store a string into a number, then I could try to do arithmetic with it. So I can say A equals A plus color. And if I run this, Perl doesn't complain, because it doesn't care that I have different types, and I can overwrite any number with a string and vice versa. And so if I have this is in the syntax here, the context is going to be an arithmetic operation. So this is going to look at this variable and say, okay, I'm going to interpret this as a number. So it's going to look at that and it's going to say, well, that's not a number, so I'll just give you 0. And but it will do that without complaining. Most other languages will say you can't do that. they'll give you an error and then you can't run it. Perl will allow you to do a lot of things without complaint, and we will learn later how to put some controls on that, so to avoid problems where you're trying to do something and you don't want it to give you a bad answer. You want it to give you a warning if you do something that you're not supposed to. Okay, so basically you do an assignment with this single equal sign. You can put variables inside of the double quotes, and we'll look at that when we look at strings. So we work with that, and then up here, you can do assignments, and you can do arithmetic and so forth, and references. Referencing a subscript of an array, that's going to be something we'll cover when we work on lists, which is right here. Lists, when instead of using the $sign, you indicate to Perl with an @ symbol that what the following is going to be treated as a list, not as a single scalar. Now, some of the information that I'm going to give you here is relevant only through Perl version 5, which is the current active version. There's a Perl version 6 that's kind of in testing phase, and I'm not sure if and when they're going to release that, but that has a little different rules. But the rules that I'm going to give you today apply specifically to Perl version 5. So if I want to initialize an array or a list, then I can do it with parentheses, and I just separate the items in the list by commas. And here I'm just using a list of integers. I can use strings, floating point numbers, things like that. Or I could put other variables in here. If I want to access a particular item in the array, then I can access it by the square brackets. Now notice here that the index of the first item in an array in Perl starts with 0, so it's 0 based. So this is index 0, 1, 2, 3, 4. So this has lists, has indices between 0 and 4, but here I'm going to do an assignment to array item 5. In some languages, if you've created an array, it's a fixed size and you can't assign to something outside of it. You can create an error or a fault, a memory fault, if you try to do this. But in Perl, what it will do is it will dynamically expand the array. It will handle all the memory management for you. So in this case, what I do is I access index 3, which is 0, 1, 2, 3. And then I add to the end of the list, and I add a 13 on the end. And then when I print it out, it should print out the list, this list here plus 13. I can cast a list to a scalar. So I put it into a context in which Perl is going to interpret it as a scalar. And in this case here, I'm just assigning the array to a scalar. And then so what it's going to do is it's going to give me the number of items in the list. I can also get the highest index, and this is borrowed from shell programming. If I say $A, then what that's going to give me is the highest index of that array. Now, if you notice that here, when I'm referring to the entire array, I refer to the @ symbol. I use the @ symbol and then the variable name. But if I refer to an individual element, Perl expects that to be a scalar. And so what I have to do through all versions of Perl up to 5 is to use a $sign. So that changes it from the full list to just one member of the list. And in Perl version 6, they actually changed that rule, but I'm not going to cover that. So the first thing that we did is index 3. That's what we expected. Here, I grew the list. And so it did it fine without any complaint. It tells me there's 6 items in there. Once I've added this, that's 1, 2, 3, 4, 5, and then this makes 6. And then the last highest index, which would be for 13, is going to be index 5. So in order to work with arrays, you have to keep these rules in mind. Hash tables are very simple, are very similar to lists. They are associative lists. So instead of using numbers as indices, we're going to use a key. A key can be any type of scalar value. And basically, if you have if you assign something to a hash table using a key, if I assign a different value to the same key, it's going to overwrite the previous value. Now, the keys can be any kind of scalar value. I don't recommend using a floating point because of rounding issues. And then the value of any member of the hash table can be a scalar value. Instead of using the square brackets that as we do with regular lists, the hash table, in order to find the member in the hash table, you give it the key inside of curly braces. Here, I'm going to use the key AGE. And notice that I don't have to put quotes around that. There's going to be a lot of instances in Perl where you're going to see where if the context allows it, you don't have to put quotes around that. If I wanted to, I could change this and add quotes into it. A lot of languages would require that. Perl is not particular about hash table references. Again, I start with %sign if I'm referring to the full hash table, the full list, associative list. But if I refer to an individual member, then I use the $sign. That tells Perl that I'm going to be working with an individual scalar. Okay. Now, if I wanted to get just the list of the keys, so that would be name, phone, and then age, that I can call the keys function on the entire hash table, and then that gets assigned to the result of this is going to be a list. So I can assign that to a different variable. And in this case here, I have a list. So when I run this, what you see is the first thing I did is I just printed out one, I looked up H sub name, which would be this, the value is Sam. And the next one is I print out the list of the keys. So I store those into this array and then I print that out. Age, name, and phone. Notice that it's not the order that I assign them in. With hash tables, it's a pseudo random order. So you can't depend upon Perl to consistently put them in any predictable order. So if you need to go through the keys in a particular order, you'll have to do a sorting, or you'll have to have the list that the order that you want in an assigned list. Before, when I mentioned the names of the arrays, I said that it's case sensitive. So if I have lowercase x and uppercase x, these are considered two separate variables. That can be tricky if you're reading through hundreds of lines of code. So in order to avoid that, I like to put more descriptive names for variables and not reuse the same name, but with different case, or different types. This is another oddity or feature, I should say, of Perl, is that if I have $x and @x or %x, then each of those is going to be separate variables. So I can have a scalar, a list, and a hash table all with the name x. That can get very confusing. So my advice is to never reuse the same name when you're working with different types to avoid that problem. Also, there's the ampersand that refers to the name of a subroutine, which we'll get to. So here, this just illustrates that you can have two variables with the same name, but different types. So if I have a list, it prints it out as this. If I have a scalar, it prints out as that. Normally, that is not a problem, but when you start doing the elements of the list and you want to do a reference here, dereference, then basically I'm going to go to index 2 of this if I'm scanning through the code really simple, or really fast, not paying close attention, I could miss this part here and just see $array and think it's this scalar that I'm working on. That's why I recommend not to reuse names. In Perl, if we're doing an assignment, as we've seen, just use a single equal sign. The double equal sign is going to be for testing, as in C, C++, and other languages. And so normally, if I'm just initializing variables, I just assign them this way. With an array or a hash table, you put parentheses around them. With the hash table, you have to have pairs, key, arrow, value, key, arrow, value. All right, now the left-hand side of an assignment is called the L value. So a lot of times if you're running Perl and you get an error that says illegal L value, basically what that means is you're trying to assign something to something that's not an L value. L value just needs to be something that is a location in memory that's reliable, like a variable name. You can also get that in certain calls to subroutines. If you give a certain argument where it's expecting something that is writable, and you give it a fixed number, then it may give you that error, an illegal L value. That's where the L value comes from. They've also borrowed from C, where you can do the plus equals, which is the same thing as equals to, the number equals the number plus the value, times equals. And then also with strings, string concatenation is done with the dot operator. So basically what this would do is this would add comma junior to the end of this string. And you can also do bitwise arithmetic. Let's say you're working on file modes, that you can do masking and things like that. When you're working with numbers, if you have just the numbers with no decimal point, and it starts with 1 through 9, then that's considered a decimal. If it starts with 0, then Perl is going to interpret that as an octal number. And so you may have a problem. Let me see, Perl I. So if I say $x equals 55, and then I say $y equals to 0.55. Okay, notice that it converted it from 0.55 in base 8 to 45 in base 10. That's not a problem unless I'm expecting this to be a decimal number. But if I had done y is equal to 0.99, then it's going to say illegal octal digit. So that only if you're using numbers that are 8 or 9 are you going to get this error. So if you add a 0 to the beginning of an integer, it will be treated as an octal. And if you don't have an 8 or a 9 there, you're never going to know that it's doing that conversion. You have the hexadecimal, floating point, and then you have the scientific notation. For strings, we have a number of ways to do quotes. We have single quotes, which interpret things literally. So the value, the text inside of that should not be interpreted. But if you have double quotes, then basically what it will do is it can replace certain, we've seen before, you can have a variable name inside of there. You can also have like \t, \n, other special codes like that, which allow you to print tabs, new lines, and things like that. So these are two ways to do quotes. There's also there's some we'll see in the operator. Oh, here I have the link here. So if I go to the Perl op man page, which is Perl operator, this gives me all of the different ways in which I can quote things. The single quote, double quote, and then I have the backslash, or the backwards quote. That will actually execute a command externally and give me back the answer through that. I can create a word list, and then these are the regular expression operators that we'll learn when we go over regular expressions. And so the normal way that you do them is with these quote symbols, but here this shows you another way that you can do them in Perl is you can say Q and then the braces, and then inside of that it's going to be treated just as if you type the single quotes. So you may have a quote in which you're using the actual quote symbol. So if you do it with this form, that can help you with that. All right. So let's go back to here. Here is called a here document, where you have double less than symbol, and then you have something that you're searching for, and then you have lines of text, and then here is the key that indicates that's the end of the quote. So if you have a multi-line quote and you want to put a lot of formatting in it, here you have tabs, you could put your variables and so forth in there, you may want to do a here document, and we'll go over the specific rules of here documents. One of the tricky things about that is the item that you're searching for, you have to put it in certain types of quotes. If you put it in double quotes, that means the string after it is going to be treated like a double quote string. If you put single quotes around this, then it will be treated as single quotes. In other words, like the \T will not be interpreted as a tab. It will not be replaced. It won't replace variable names and things like that. And we'll see examples of that. And then another thing which is a little bit difficult to remember when you're first learning is when you do a here document, the semicolon goes at the very beginning here. And so then you have your quote and your whatever the search symbol that matches. And if you have the semicolon down here, then it's not going to match and it doesn't work. So this is where you put the semicolon, which can be a little bit, non-intuitive. So here's some examples. If I create a variable called name, I store a single value into it, I can either print it out with double quotes or single quotes. Here I'm assigning these to new variables and then printing them. Notice that here when I do the print statement, I'm using double quotes. Well, actually, these are not inside of it. They're just in a list here. So I have one quote, comma, the variable, comma, another quote. So basically the print statement, it treats this list as I'm going to print this, then I'm going to print this, and then I'm going to print this. So when I run this, you'll notice that this format where I use the double quotes, it replaces $name with the value, which is in the variable. Then this form here, I have single quotes, so it will take $name and it will print it out as $name. It will not do any replacement. All right, here's an example where I use a here document. And this is multiple lines, and inside here I have variables, I have \T, and so then if I run this as is, then it's going to align these up with tabs, and it replaces the variables with the all of the values for those variables. If I change this to single quote, yeah, see, Jupyter Notebook is going to try to be helpful and replace that. So if I run this again, okay, now it does no interpolation. All right, so let's look at operators. The numeric operators are going to be the same as in C, C++, Java, but you do have the double asterisks for exponent. For string operators, you have the dot, which concatenates two strings, glues them together. X for repeating characters. Then we have regular expression operators, which we'll go through. And then we have a lot of logical operators borrowed from C, C++, Java. or their English equivalent, and we'll look at how those are different. And then relational operators, and those are going to be different based upon whether you're comparing numbers or whether you're comparing strings. So if I go to this man page, we already opened it up before. This will give you all kinds of details on the different types of operators that are defined, and you can find more information there. The one that I'm most interested in is the operator precedence. And if you look, there's different types of operators like this, the arrow symbol, there's plus, plus, minus, minus, exponent. And this gives you the order in which it takes precedence. So multiplication, division, modulo, those happen before addition and subtraction. Exponent occurs before those. And then if you have the inversion, the logical inversion, that falls somewhere in between there, and then the increment and decrement. And then if you look, there's these double ampersand, which means and logically, in a logical statement, say if this is true and that's true, or the or statement. Then there's the not up here. So notice that if you're having some sort of expression that you're evaluating, and you want to know, is this true and that's true, or this true or that's true, the order of precedence, if you have multiple operators in there, different types of operators, if you have these logical statements, illogical operators, it may be a little confusing, the order in which you use it, and you can always solve that by putting parentheses around things. But the one nice thing about Perl is all of those operators, logical operators, can be done with the English equivalent. So instead of the exclamation, you have the word not. Instead of double ampersand, you have A and D, and or, and exclusive or. And those are all lowest precedence. So if you constantly use the English words for the logical comparisons, then you know that your formulas are not going to be interpreted in a weird way. It's more predictable, and I prefer to use these forms instead of the symbolic forms. The plus plus and minus minus, those are borrowed from C, C++, and if you do it after the variable, it first gives you the value of the variable and then it adds one to it. And if you put it before the variable, then it will add one to the variable, then return that result. And the same thing with the minus. Percent is for modulo. Two asterisk gives you exponent. If you're doing a comparison to see if two values are the same, you need to use double equal sign. If you use a single equal sign, that's an assignment. And sometimes Perl will allow you to do that. And that will give you unexpected results. You also have the greater than equal or less than equal, and greater than equal or greater than, less than, and then not equal is exclamation equals. If you're comparing things string wise, like you would, or if you sorted them in dictionary order, then you would use, instead of the symbols, you would use two letters. So in Perl, it is EQ for equal, LT for less than, LE for less than or equal to, NE for not equal, and so forth. And if you look at this this page, if you can go through that, and it will give you a list of all of those operators, and you can if you're not sure about which one to use. Another nice thing about Perl is it has a special operator that's going to give you a value based upon the comparison between the left hand side and the right hand side, whether it's numeric or by string. If you're trying to do some sorting, then what's going to happen is you have one number on the left and another number on the right, and you say, well, is this number less than this? If it's less than this, then the value, the result of this here is going to be -1. If these are the same, it's going to be 0. And if the right-hand side is greater than this, then it's going to be 1. And if you're comparing strings, you use CMP. So you can just think that when you're doing comparisons, numerically, it's with symbols. Strings, it's with letters. And they have the same number of characters. There's 2 characters for a basic comparison. And then for the sort comparison, it's three characters. So less than, equal to, greater than, or CMP. These are the logical comparisons. So I want to see, does this variable here, does that evaluate to true? And if that does evaluate to true, then I say, and does this evaluate to true? So this and this both have to be true. This is for not, this is for or. So E or R. So either one of them is true. And as I showed before, you have the lower precedence, you use the English letters instead of the symbols. So A and D, not, or. There's also something which is borrowed from C, which is the ternary conditional, which says, make this comparison. If this is true, then the value of this entire string here is going to be the part before the colon. Okay, so I'm going to say, does the denominator equal to 0? Is it not equal to 0? If it's not equal to 0, then I do this division. If it's equal to 0, then I'm going to return back the string indicating that it's infinity. All right, for operators, for string operators, I can glue 2 things together. So I can take a string and I can glue it to the value of the variable. And then this will just concatenate those 2 strings together. I can assign that or print it as is. If I want to repeat a string 10 times, then I put the string, either the literal string or a variable, and then I say times 10, which is, and here I'm saying X for the repetition variable. And that's just the basic character X. And another thing that I can use is the range operator. Here, if I have a list of numbers, or I want to go through an array or something like that, I can start with the lowest number, dot, dot, the highest number. So if I want to iterate through all of the items within an array, the at symbol ARY, I can start with index 0 and go up to the highest index within that array. So this is a nice, very compact format for how to go through all of the indices within an array. Okay, so here let's look at working with the strings. If I have 2 names and I want to concatenate them as first space last, then I just have the variable name dot, and then this is a literal string, and then dot, and then the other variable name. Or I can also print them out as last comma first. And here I've taken advantage of the double quotes and just interpolated it inside that. So this is going to print out the name in 2 different ways, last comma first or first space last. Here I'm going to repeat this 10 times. And then here I create a list of a bunch of numbers from 1 to 55 and then print that out. Okay, so here we have last comma first or first space last. And then I repeat that same string 10 times. If I want to, I could get rid of the space, put another, so that crams it all together with no spaces. So those are those operators. In Perl, if you have an if statement, you can follow it with, you can just have an if by itself. You can have an if and an else. And then this is a more complicated format that says, if this is true, then do something. If it's not true, then we're going to do another test. If it's not true, do this other test. If all of those are false, all 3 of those are false, then this is the last one. Now, I don't have to have an else if, I don't have to have an else. Those are optional. Notice that the else if in Perl is lacking the second E, which is kind of unique for that language. So here I start with a number, and then I'm going to go through and I'm going to compare it, see is it greater than 90? No. Is it greater than this? No. And it finally drops down to that. So let's say, okay, I improved my grade to an 84. I run it again, and then I get, it gets to this point here. I get a B. Now, in Perl, there's many different ways to do a lot of things. It has a lot of variations. So instead of using if, I can use unless. So I say unless this is true, then this is going to be the case. Notice here, if I was writing this in C, I wouldn't need the curly braces because I could just have a condition and then one single statement, and then else, and then another statement. But in Perl, you always have to have the curly braces around the code block, whether it's one command or one statement or a list of statements. And that's, it can be annoying, especially when you're switching from another language. Here's another way. This is another way to do the same thing. Basically, instead of doing these tests first, I'm going to do the opposite. I'm going to do the inverse of this. So unless this grade is greater than or equal to 70, it's an F. Okay. But if it's greater than or equal to 70, then I'm going to use this ternary condition here. So first I test if it's 90 or above, and if that's true, this is the value. If this is false, then I have this part here, and this I put it in parentheses just to make sure that it's evaluated correctly. And then this part in the parentheses, I do another test, and if that's true, it's this one, and if this is false, then it's this one. So I accomplish the same result with a fewer lines of code. And so this does the same thing as we did before. There's a new feature in Perl as of 5.14 that allows you to do a given and when, which is similar to the case and switch in C, C++, Java. But one of the things about it is you have to add this line here because normally if I just put this statement here without adding this, let's comment this out, then it's going to say, oh, this is syntax error. So I have to make sure that it's using 5.14, the specific feature. Okay. And then it says, all right, this is experimental, and it'll give me warnings for all of those lines. It will give me results, but I get a whole bunch of warning messages. This directive here turns off those warning messages. This indicates, yeah, I know I'm using this experimental feature. I don't want you to complain. So then when I run, it does it correctly. Okay. And another thing that I can do, if I don't like that here when I'm doing if and else that I have to use the curly braces, what I can do is I can put if I'm just saying if something is true, then do this, and there's no else, I can put the if after the statement. So I can say print this if this is true. I personally find it a little confusing if I put it all on the same line. So if I'm scanning down a large program and I just see a print statement, I say, well, why didn't that print? I have to scan to the end of the line to see, oh, there's an if statement. So what I like to do is I put the if on the next line, just indent it a little, and that's a little easier to see as you're scanning through. And you can either use an if or you can use an unless. And here, it's just test the name, and this uses a regular expression, which we'll go over. And then if the name does not start with a capital letter, it's going to print this message out. Another thing I can do, which is kind of similar to this, is I can use logical operators. Well, when I'm using an and or an or in Perl, if I have A and B and A is false, Perl is lazy. So if A is false, it's not going to evaluate the next one. A lot of languages, that for optimization, they'll be lazy as well, but many languages are very pedantic, and they will evaluate this. If it's false, they will still evaluate the other one. And so if you have some sort of problem with the second statement, like say you're dividing by 0, it'll still evaluate that and generate a problem. But in Perl, it's lazy, so you can say, well, let me make sure that this denominator is not equal to 0. And if it's not equal to 0, then I want you to assign the quotient. And this is similar to similar to this form here, where you have you don't have to put the curly braces, and it's a little simpler. But here you have the condition first, and then the statement that you're executing. Now, Perl doesn't care. I'm using a logical operator, so you would expect that, okay, I'm going to do a test, and then I'm going to do another test. But in this case here, I'm not actually doing a test. I'm just doing executing a statement. And Perl doesn't care. It's just going to say, well, if this is true, then I'm going to evaluate this, and then it will just execute this and do whatever. The same thing here. I test to see if a file exists. It's a regular file, and if it doesn't exist, then I'm going to quit the program and print out, the file doesn't exist. While loop is very much like other languages. While some condition is true, keep repeating. So for a basic while loop, I can initialize a variable, and every time through, I make a change to the variable, and then do some operation within the loop. This is very simple, much like other languages. There are other types of loops in Perl. One of them they borrow from the C language. Here they have the 3 clauses separated by semicolons. So you have the initialize, test, and increment for the for loop, and it starts at 1, goes up to 9, and then increments by 1 each time. And this is the same thing as if I had a while loop like this. It just puts it in a more compact form. And so when I run it, it's very basic. You can play around with these. Let's say I wanted to make it cube. Then I can do it that way. All right. Another thing that it has, which is kind of nice, is it uses for each, which is borrowed from the C shell. And here I start with a list, and I want to go through every item in the list and do something with it. And in this case, I'm just going to print it. But it could be a list of numbers, and every time through, I need to do something complicated with that. But the for each says for each time through the loop, I'm going to go iterate through all of the items which I specify in the list, which can, in this case, is a variable, or it could be, a call to a function or something like that. And then, but I have to prepend it with the loop variable. In this case, I'm specifying that $call is going to be assigned each value in this array. So each time through the loop, call is going to have red, orange, yellow, green, blue. So I run this, and it operates like that. All right. If I want to go through all of the indices within an array, we saw before with the range operator, the ... I can just say for each I, and then you start with 0 and you go up to the highest index of the array, and then you're going to do some operator. So here I have, I go from 0 to 20. Oh, this is not actually using the array. So, yeah, okay. But if I was going to work with an array, let's say I've already initialized this list here at symbol ARY, and then what this will do is it will go through 0 through the highest index, and it will not, I don't have to worry about, okay, I don't know the size of the array beforehand. This form here just allows you to, it will dynamically go from 0 to the end of the array, and you don't have to keep track of it separately. I can similarly go through the items in a hash table. I can say for each key within, and then I have the keys to the hash table. And so what this will do is it will go through each one of these, and then it will do some sort of evaluation, and it will do an operation. Okay. Another thing, instead of just going through the keys with a hash table, I can have key and values. So instead of using the keys function, I can call each on the name of the hash table, and I have to put percent hash table to refer to the entire table. So each, what that will return is it will iteratively go through the hash table and give me a key value pair, and it returns as a list. And so on the left hand side, what I can do, which is nice in Perl, is I can assign, I know it's going to be 2 values, a list of size 2, and so I assign the first value to $K and the second value to $B. So that's the key and the value. And so then I test the value, and if it's above certain, then I'm going to do this with the key, which is the same thing I did up here. It's just a little bit more compact. There's also another function that's even, you don't even have to do a loop. You just call a function, and the function will do the loop for you. And here what I do is I go through each of the keys within the hash table, and for each one of those, I'm going to execute this bit of code. And here I have to put it within curly braces. I could, instead of having the code here like itself, I'll give a reference to the name of a function, either a function that I have defined, or let's say I could call sort, or grep, or some other function like that. One of the things here is each time through, I'm going to get a value for the keys, and then when we did the for each loop, the keys get to assign to this variable here, name, and then I'm using name within the context of the loop. Down here, if I'm using map, well, I don't specify the name of a loop variable or a variable that map is going to use. So what map does is it has a implicit variable in Perl, which is $_. And this is implicit in a number of functions where you needing to do operations on a particular variable. And if you don't specify that variable, like with a map function, there's no way to specify that, then it assigns that to $_. So every time through the map will go through, iterate through all of the keys, all of these 3 keys, and each time through, it's going to assign the value of the key to $_. And so this is the same as this and the same as that. Map is very useful if you just need to do something simple to a list and you don't feel like writing a whole loop, or things like that. Now let's look at some of the syntax errors and how we can deal with them. Here I'm going to try to get a random number between 0 and 1. This is the RAND function, and then I'm going to test that to see, is it greater than 0.5? Then I do something else. Okay, so if you're used to programming in other languages, you forget to put the curly braces around it. So it's going to give you all of these messages, and okay, a lot of these are from Anaconda. So that's this, because this is wrapped within the Jupyter shell. Like if I ran this on the shell, then I would probably just get these errors here. So you can ignore all this stuff here, but it's going to say line 6, 1, 2, 3, 4, 5, 6. And it's going to complain that it reaches here and it says, well, you have a if statement, but you don't have a statement block. So I always have to put the curly braces on here. And then when I run it again, then I get my expected result. And there, nothing happened. Okay, so it's random, so you can keep running it over and over. Sometimes you'll get this, sometimes you won't. Here's another common error. I'm trying to do an assignment here and see if you notice what the problem is before you run it. Can anyone figure out what the problem is? In this program here? Okay, so let's go ahead and run it. And here it's going to say syntax error line 4. Well, what did I do here? I'm just trying to make an assignment. What I did in here is I forgot to put the dollar symbol in Perl before a variable name, unless it's a file handle, which we'll get to, is you always have to put dollar or the ampersand or %sign before a variable to specify that it is a variable. Okay, so that solves that problem. Now, a lot of problems will happen if I run this code here and I want to go through the lists and array and I want to test to see if it's equal to 7 and I want to print it out. Well, here I keep getting the value is 7 for all of those. Can anyone figure out what I did wrong here? Okay, you can put the message in the chat if you know what the problem here is. Okay, this is something that occurs a lot in C, C++, and other languages like that. You put a single equal sign, yeah, that's as an assignment. So if I put the double equal sign, then that's going to be correct. But if I ran a complicated program and I just had some kind of statement like this, which I thought was doing a test, and it does some operation, I may be getting completely wrong results without knowing it. If I turn on warnings, so I have this directive at the top of the program called use warnings. Once I do that, then it's going to say, oh, wait a minute, on line 9, you have a single equal sign, which should be a double equals. So once I see that, if I have warnings turned on, then if I run it, then it will alert me to where my problem is. In Perl, there's a difference between an error and a warning. A warning is non-fatal, and as we saw before, it'll run, it'll give you the result, and then it will say, well, wait a minute, you have an issue here. You might want to look at that, but it'll still run. An error is going to be something where it tries to divide by 0, or it tries to open a file that doesn't exist, and it says, oh, I have a problem. Here's the error, here's the diagnostics, I'm gonna quit running at this point. An error can be found at compile time. Let's say that I have some syntax error. Then when Perl runs, it will first compile the entire program and look for any type of issue with syntax. And if it finds a problem, then it's going to say, oh, you have syntax on line 55. And then it will never run the program. Runtime error can be something like dividing by 0. You have some error with the pointer reference type, hash versus list, some sort of object method where you use the wrong type of object. And those can be runtime errors that you don't know. It compiles it, everything looks fine, but it doesn't realize that there's a problem until it's actually running. And then it starts running, and then in the middle of execution, it gives you an error, and then it quits. So if you are wanting to deal with, make sure that you get warnings in case you do anything, any common problems. When you run Perl, you can either put a -W on the command line or at the first line on the shebang Perl, and then you add a -W there, or you can put use warnings at the beginning of that. So here, we're going to look at this program bounds.pl. So okay, so this program, it has a list of size 2, and then it tries to add 3 items together. Well, obviously, a sub 2 doesn't exist. So let me, okay. Perl bounds.pl. Okay, it gives me an answer, but if I'm expecting that this formula should have a value here, but for whatever reason this list does not have that there, then I need to know. So what I do is I say Perl -W, that turns on warnings, and that says, oh, hey, on line 7, you have an uninitialized variable. So when I have warnings turned on, then that allows me to notice where the problem is. I can either do the -W when I call it, or I can do use warnings at the beginning. So if I do that, it gives me the warning. The same thing with the equals, if I'm doing a comparison and I put a single equal sign, if I don't have the warnings turned on, then it's going to give me this. If I do use warnings, then it's going to give me a heads up that so I can fix it. All right. So here's another one, senderror.pl. That's a bad name for a file. It just invites problems. So now I have this. I say, okay, there's while something, and then I can't find string terminator. So let me edit this file. Okay, line 6. All right, and let me fix that. Okay, so I fixed that problem. Then it says, oh, I can't find the string terminator, and line 9. So if I go back here, I go to not line 9. Okay, I have a quote here, but I don't have a close quote. So those are errors that it will not execute the program until I correct the syntax errors. With the runaway strings, that one, the one here for syntax error, it has a single quote or a single string at the very end, and so it's obvious that that never ends. But if you have multiple strings within a program, let's say close eq.pl. Let's say here I'm trying to assign a string here, but I forgot the close quote, and then I have another string down here. Then what it's going to do is, oh, it's going to give me all this information here, and it didn't find a problem until it got to line 8. So if I print this out, line 8 is where it had the next occurrence of the double quote symbol. So here, by strict interpretation, Perl would say, okay, $name is equal to all of this up through here. And then it has this symbol and says, oh, I don't understand what you're talking about. Okay, so it'll say, okay, you have a problem on line 8, and then it makes a suggestion. This might be a runaway multi-line string starting on line 3. So you go back to line 3. So it's very, very useful when you're executing a program to scan through the error statements, because you may get many, many lines, and it may be a little confusing, but just go through them carefully. And if it has this suggestion, try to trace it back to where the problem originated. Now, those are errors that occur when you're at compile time or runtime. But one thing that you can do is, if your program compiles, you can put in some diagnostics so that you can control when the program executes and when if it has an error, what information you're going to give yourself. So there's the die function, and that prints out whatever string you have here, and you could even print out the variable contents if you need, diagnostics. And this says if a certain condition is true, then print this out and then quit the program. Now, if I put a space at the end, what Perl will do is the die come in, it will print this out, and then it will print the line number of within the Perl program, which is nice because that way you can say, okay, well, I know I have a problem, but where in the program is the problem? So if you don't put a new line at the end of the string that you're printing out for die, then it tells you the line number that you're working at. Or minus sign F, that's a shell borrowed from shell programming that tests to see that the name of the file specified by this variable exists and it's a regular file. And it's, in other words, it's not a directory, it's not a pipe or whatever. And so if this file exists, then you're good. Or if it doesn't exist, then I'm going to die and I'm going to print out. And then here I use the name of the file name, and that's good for diagnostics. So let's say earlier in the program, I was supposed to assign something to $myfile, and it turns out that I did that assignment wrong, or there was some other source of error. By printing it out here, I can at least know what it's trying to open. So maybe this was misspelled up higher in the program, or maybe it's something that the user has to type in and the user typed in something weird, or they had a typo in the name of the file that they typed in. Okay. Instead of using die, you can use warn, and warn will do the same thing. It will print out a message to standard error, and but then it will continue to execute. And you can also, put a space at the end so that it will give you the line number. There's also a library, and you can look at the perl./carp, and this gives you examples of how to do. There's different functions. They can give you a stack trace and things like that. That's beyond the scope of this class, though. But if you're wanting very useful diagnostic informations in your program, you can use the carp library. Another thing is when you're printing out an error message, let's say I just called the open function to try to open a file. If that failed, in other words, the result of that is a failure, so I wasn't able to open the file by this name in read mode, then what happens is this will return back false. So I say or, so if I successfully open it, it's true, then it'll keep going. But if it fails to open, then it's going to print out this message, and it says, okay, I'm trying to open this file by this name, and then $! That's a special variable in Perl which allows you to print out whatever the diagnostic information is. It sets the error no. Like if you're doing C programming, it would set the variable error no, and then you can print out what does that number represent. And in this case here, $! is the system error string corresponding to the error number. So basically what this does is if I'm trying to run a program and it tries to open it, but it fails, I'm going to say, oh, why did it fail? Okay, here it says because no such file to directory. All right, and then it's looking for the file need file. So here I do Perl no file. It's tried to open need file. So let's say touch need file. So I created that file. It's an empty file. So if I run it again, then it's able to open it. But let's say, for example, chmod -read write on need file. Okay, so now I have no permission to do anything with it. So then if I try to run this, and say, oh, permission denied, or if it was owned by somebody else or something like that. So notice that the dollar exclamation, it's going to change. In the first case here, it said no such file or directory. And in this case here, it says permission denied. So that's always useful if you're doing, system calls, working with IO and so forth. That gives you diagnostic information on what the problem was. All right. When I'm using variables in Perl, to declare a variable locally, there's a keyword called my. So I say my $A, my $F, things like that. There's also a keyword local. That is a little bit confusing because it's literally is not used the way that you might expect. You might say local is, oh, that's a local variable, but it has a different meaning in Perl, and I'm not going to cover that. Basically, we're just going to use the keyword my. Now, if you're working with multiple Perl files, like you have modules or multiple files that you include, you can use our, and then that gives it the scope within the entire file. So you put my before a variable name, and you can also do initializations. You can make a list. I can do my and then do a whole bunch of them. I always have to put parentheses around them if I'm declaring more than one. Okay, so what my does is it tells Perl, okay, I want you to set aside this variable, make sure that this is available to me within this scope that we're working in. And as soon as we exit that scope, that variable goes away. So let's say this is inside of a loop, then it's only active until the loop ends, and then it gets thrown away. Or like in this case here, I have a loop variable, and I need to declare item. And if I put it before the loop, if I said $my item, then that would be outside of the scope of the loop. But if I put it here, right as I'm using it the first time, then this is a declaration that says within the scope of this loop up until I get to the end, the last iteration, I'm going to set aside this local variable $item, and that gets used repeatedly throughout the lifetime of the loop, and then the loop ends and that goes away. Okay, so here, let's see. Okay, here I have a loop variable $item. I've declared it here, and I'm using it within this loop, and then I try to refer to it here. So let's look at, well, let me first. Okay, so this is the program where I have this local variable, and it should only be used here, but I'm using it outside there. So if I say Perl scopex.pl, then it gives me what I expect, but outside of the loop, it's a null value, because this variable here does not relate to what this is. So if I had assigned item up here to something else, let's say I said item was not defined, I could set it to whatever I want here, and then I run it. Okay, so that doesn't get erased by this because this is a local copy. And so the value, I'm sorry, let me cat that out again. So this use here, $item, relates to this value here. And this $item here is in a local scope. And so this ignores whatever I had out here. So these are two different locations in memory. Those are two different variables according to Perl. Why do I declare a variable? Well, one reason that I could declare a variable is that if I use a variable and I haven't declared it, then there may be a problem with that. it may just be that I was too lazy to declare it, or it may just be that I misspelled the name. I have a typo in the name. So if I turn on the pragma use strict, I use this directive here, use strict at the beginning of the program, then anytime I use a variable, if I've not declared it, it's going to give me an error. It says, okay, at this line 3, you have an assignment to a variable, but this variable has not been declared. Okay, so I can solve that by just doing this and run it. For a very simple program like this, it doesn't really make sense. But if I have a very long program, and let's say I declare some variable names, and then down further in the program, I have a typo in the name of a variable, or let's say I have a uppercase letter that I didn't notice. If I hadn't declared that before, then turning on use strict will save me from the problem of having the wrong variable name. It will alert me and say, hey, you're using a variable name you didn't declare before, so there's a problem here. Now, if I'm working with IO, there's 3 basic streams that are built into Perl: standard in, standard out, and standard error. Those correspond to the same within C or C++ and a lot of other languages. Standard in is whatever you type from the keyboard, or if you're piping it in from another command or reading it from a file, then you can that goes to standard in, and you read from that. Standard out, standard error, those are output streams. If you are just printing a normal print statement, it goes to standard out. If there's some kind of warning or error, it goes to standard error. And those, if depending upon how you execute your Perl command, let's say, let's see, Perl no file. Okay, so let's say if I pipe this to my output, okay, the standard error still goes to the screen because the redirect symbol in bash, that only redirects standard out. So if I say cat my output, that's an empty file. But if I said, okay, to errors, okay, then what that does is that will capture the errors that redirect standard error to that file. So you can play with that. That's more of a bash thing. But standard in, standard out, standard error, you can use those features in Perl, similar to with a C program, and then you can create your own file handles. The old style file handles are like this. They have just letters with no $sign before them. And that was the original format for working with file handles in Perl. And the convention is, if you're working with a file handle, to put it in all caps. That's just to help you, know the difference between a file handle and another type of data. Or you can use a scalar variable. Okay, so I can say $x is equal to open, blah, blah, blah. And then you can also work with objects, and we'll look at that. If I want to print values, there's the print command, just basic by itself, and that you give it a list of items, and it's going to print them out as a list of strings, one after the other. And you also have the printf command, which is from C, C++, Java, which you can do formatting in there. You can format your numbers and, do the, special, precision and things like that. And then if you're working with binary files, you're going to use these. These are both buffered. So if you open up a file unbuffered in binary mode, then basically you're reading it into binary data, and then you're going to output it as binary data. Then you use syswrite. You can't, if you've opened a file in a buffered mode with regular open, you can't use syswrite. You have to use sysopen. Okay, if you're going to be doing any unbuffered binary data. And that doesn't necessarily have to be binary data, but that's generally how it's used. So it's open in mode where it treats it as binary data. Now, if I want to print to a file handle that I've opened, which I can specify standard in, standard out, and standard error, or I can, let's say I opened a file and I gave it a name and I put it, assigned it to the file handle FH, then this is not formatted right. So basically, yeah, this has the markdown. So this is supposed to be, print FH list, and they should be in, yeah, they should be italicized, but this, for some reason, it's not doing the formatting correct on that. So it should just be without these asterisks. Ignore these asterisks. I'm not sure why it does that. So you would just have print and then the file handle and then whatever you're printing. Notice there's no comma between the file handle and the arguments. The same thing with printf. You have to do printf, the file handle, the format string, and then you start putting commas between the arguments. So the commas only go after you start putting the data in. Syswrite is a function. So the first argument is the file handle, comma, and then the rest. So here's examples. In Perl, if I'm calling the function, I can put parentheses around the arguments, or I can leave them off. But if I'm calling print or printf with a file handle, I don't include the file handle inside the parentheses. That has to go outside the parentheses. When I'm reading from an input stream, either standard in or a file that I've opened, the operator in Perl is the less than greater than symbol. And so if I have nothing inside that, that just means read from the standard in. Usually it's from the keyboard. If I put the name of a file handle in there, then that says, okay, I opened a file handle with this name, and you're going to read a line from that file. And these are both buffered. So if the file, if it's taken a while to, if you're reading a whole bunch and it may have to pause and wait for the disk to catch up, and then it has to sit there and wait. And so that's called buffered. So it may read a whole bunch of stuff in and save it in the buffer, and then you're just reading from the buffer. Now the system level, this is not buffered. Again, you can't mix these two types. And in this case here, you put the file handle as an argument, and then the name of the variable, and then the number of bytes or characters. How do I open a file in Perl? Well, there's the open function. And if I go to perldoc.perl.org, and I want to look at functions, and open. Where's open? I'm missing it. Open. Oh, here it is. Oh, functions for file handles. All right. So here, if you read this man page, this will go through all of the different ways that you can use the open function. And we don't have time for this class to go through all the variations, but I'm just going to show you a few examples. One example is if I want to open this file for input. Here I have a character which means to read in the normal mode. So I just say open info.dat, and all you're going to do is read from that. So then this attaches this file handle to that open file. As long as it opened correctly, then I can just do inputs from this file handle here. I can also, instead of using the old-fashioned style, I can use a scalar number or a scalar variable, $, and then the variable name. And here I'm creating a file for output. Now there's different modes. I can do a read, I can do a write, I can do a append. Be very careful if you're opening a file in write mode, you'll overwrite whatever was there unless you use the append. Okay. Now Perl allows you to write to a file or read from a file, and then when you get to a certain point, and then start writing to it. But you have to, the operator for that requires that you put a plus symbol here. It doesn't really make much sense to do the write with the plus. It makes more sense to do the read, but basically, if you use it like this, then you can do reads and writes to the same file handle. And what this does here is this allows me to open this file here for reading, but if I want to, at whatever point, after I've read so much, I can start writing to it. So if I'm in the middle of a file and then I start writing, then it will keep what I've already read, and it will overwrite everything after that point once I start doing a print. And then here, if I want to append to a file, and notice you can either put the name of the file inside of quote with the operator, or I can put file handle, the name, and then the operator. So like I said, if you go through this open, it gives you all kinds of examples. It shows you how to do the open and call open in different contexts. So here, let's say I want to open a file for reading. I read it in, and then I open a file, and I'm going to append whatever I output to that. So to go through the file, I can use this read operator, and then this is the name of the file handle. And what this does is it will assign to the variable $line one line from this file here. So every time through this loop, it's going to assign the next line from the file into this variable here. As soon as I get to the end of the file, then this construction here evaluates to false. So once I reach the end of file, then when I do an assignment from this read operator, it will evaluate to false or to undefined, and at that point, that makes this while loop end. So this is a very common construction for going through a file, reading it line by line, assigning the value to line. Okay, and then what I do is I call some routine that I wrote that evaluates that line, and it's going to do some parsing and put some information into it's going to return that as a result and put that into this array here. And then I'm going to call printf, but I'm printing to this file handle. Okay, so here I have the file handle, and remember, I don't put a comma here. Then I have my format string, and then comma, and then I have my arguments. Okay, and in this case here, I hope that ampersand useful has 1, 2, 3 items at least. If it doesn't, I'm going to get an error when I run this. You can also use pipes, the open, and what this can do is I can call a program, let's say PS minus AUX WW. That gives a big long list of all the processes which are running on the system, and it's a very big long list. And so if I want to write a program to process them line by line, what I can do is I can, within my Perl program, I can say, go ahead and execute this and take the output of that program, and then I want to be able to read from it. So I start reading from PS, that file handle, and every line of PS, I'm going to do some operation. Here, I'm going to call the grep function. I'm going to say, okay, I just want the ones that are not owned by root or Apache. Okay, so those are, that I winnow down my output from that, filter it, and put it into here. And then I want to work with, with that, print out those values. So let's put this into practice here. If I run this, then I have a number of system daemons that are running, and I have here's a process that I have running. I'm running a job. This is the actual, since the Jupyter notebook is running within the batch system, this is the program that's being running. This is the process. And then I have a few other users who have programs that they're running. Okay, Now, if I want to read from a file that has some sort of, special character set, there's an encoding here. So what I can do is I can do it this way. It's a little bit tricky, where I say open it, and then I put the encoding after the operator, and then I have put the file name. Like I said, if you read this will go through those examples here. I don't have, we're not going to cover all of the encoding there, and that's very useful if you're working with, different types of data. If you're working with binary files, you remember you can't mix and match. So you always have to open it with system opens and system read and system write. If otherwise you just use the regular open and then use these operators. But this is for non-buffer, this is for buffered. Let's say if you've written to a binary file and you just taken some structures, some data structures in C, and you've dumped them to a file as is from memory, then there's a tutorial here, Perl pack tutorial. And if you go through this will show you how to, you start with your C function, your C, and then it will show you how to convert that into the format that Perl can convert the data that you created in your C program and convert it into Perl variables. So I've used that a few times. If you're working with binary data, that's where to get started on that. So let's go to regular expressions. This is a very major part of Perl. A lot of languages, you may see other languages or software packages where they refer to a Perl regular expression. So the regular expression comes from Unix. They've been around for decades. Ed, grep, vi, awk, and Perl added a number of special operators and things like that, which gives you a little bit more power for regular expressions. That's one of the advantages to using Perl, is the regular expressions. So let's look at some examples of how I can match a pattern to a string. If I have a string in this variable here, what this operator does here, this will bind this search pattern to this string and test to see if it's a match. So equal tilde means does this, what the left hand side, does this match the pattern on the right hand side? Now the right hand side has to be in the form of a pattern. We'll see there's a few different ways to do that, but the normal convention is just use / and then you have the whatever your pattern is. In this case here, I just have capital M ICH, so that will match anything that starts with those 4 letters, and it will not match if it's a lowercase. It will not match if there's a space or a dash or anything like that. So it has to literally match those 4 characters. Regular expressions also allow you to have a number of meta characters that have certain meanings. The caret symbol means the beginning of the line. The square brackets is a character class that says, okay, I'm going to give you one of these. It can either be an A, B, C, or K. So this will say, okay, I'm starting at the beginning of the string, and then I have to have one letter and then SH. So that CSH will match, KSH will match, but bash, you might think that bash would match because it's B and A and then SH, but this bracket means only one character unless you qualify it. Okay, if I have a backslash before a character, that's called an escape, and that says instead, so the dot normally means any character. It will match any character, and that depends whether it matches the new line on the mode that you're in, but don't worry about that right now. And the asterisk means one or more of whatever the last thing that you told me. I'm going to match 1 or 0 or more of those. Okay. So this matches any number of characters, including an empty string. And then the literal dot, because a dot is a meta character. If I put a backslash before, that means I have to literally match the period. And then I have a C or an H, and then $ anchors it to the end. So what this says, I need to look to see if this file name does not end in .c or .h. Okay, so if I'm only searching, if I have a list of files and I want to filter out the C source, I can do that. Another thing I can do is I can do a substitution. So here I'm attaching this regular expression operation on the right-hand side to this variable here. So I have a command and I want to say, okay, instead of matching, I want to do a substitute. The S is for substitute. Now, normally I would just say S and then slash, but here, part of the operation that I'm doing is I'm gonna match the beginning of the string, and I'm gonna replace the beginning with these. I'm gonna add this to the beginning of the string, because this matches just the very beginning of the string and no actual characters in the string. And what this does is it just inserts that string into it. So instead of using the slash here, since that's part of the replacement, I use a question mark. So Perl is very flexible. If you look at the, let's see, there's a tutorial on regular expressions. So I would look at the tutorial, regular expression tutorial. That's very useful, and it will go through a lot of the material that's beyond the scope of this class, and it will explain how to use different symbols rather than the conventional slash, and then you can use braces and parentheses and things like that. There's also transliteration. It's like the TR command in Unix that says, for all of the characters within this range, you're gonna replace them with all of the characters. So the capital A gets replaced with lowercase a, capital Z with lowercase z, things like that. And if you look at that, the operators, there's different ways to do them. Instead of TR, I could do Y. And instead of having backslash, I can say M and then whatever symbol I need. And that says, okay, we're doing a match. So instead of using the slash, I can do that. I can also pre-compile patterns. So one of the things about Perl is every time you execute it, it has to recompile it. So if you're using a pattern over and over and over, then you can pre-compile it, so it doesn't have to, compile it every time it does the evaluation. If you know it's going to be the same. Now, normally it will pre-compile it as long as it's a fixed string. But let's say you had a name of variable in there. Well, you could pre-compile it with that variable name, and then it wouldn't assume, well, since you have a variable name, I'll have to recompile it each time. But if you explicitly pre-compile it, that saves you, some performance. How can I use regular expressions? Well, one of the things you can do is you can do tests to say, if this is true, then do this. If that's not true, do that, or do substitutions. But you can also use regular expressions when you make calls to certain functions. So let's say I want to split a string based upon some kind of boundary. Well, I want to say for this one, I'm going to separate this into different fields, and this field separator is either going to be a colon or a comma. I want either one of those to be able to split it. Then that allows me some flexibility, so I'm not stuck on having one symbol for a field separator. And notice that this is a character class within the square brackets. That means it's either one character or the other. I could have a more complicated one if you need something like that. Grep is like the Unix command grep. You give it the name, or you give it a pattern, and then you say, okay, go through this list, the arguments, whatever. You can either have it explicitly like this, or a list variable, or I can have a whole bunch of arguments separated by commas. And then each one that matches this as true, return that back. So here's an example how I use it. I start off with a string and it's separated by colons. Then when I'm going to split it, and what it does is it removes the separator character, and then the first item that I'm putting in the result is going to be the first string, and then the next string. And so this basically does a split. Is this creates it like a record, and it splits it into fields, and then I can print that out. And then I just want to look the ones that only have start with a capital A, and so then the full one is this, and then if I do, oh, it starts with an A and ends with an S. I'm sorry. So I'm anchored it to the beginning and anchored it to the end. The first symbol has to be capital A. The last has to be lowercase s, and it can have anything in between. Okay, so that matches these two, but it does not match these two because they don't qualify. And there's a lot of, like I said, the regular expression tutorial, I recommend going through that if you're first learning it, or if you want to know, there's a lot of powerful features in Perl that are very useful. If I want to repeat something 0 or more times, it's the asterisk. If I want to repeat it 1 or more times, then it's the plus. Or I can explicitly put how many times that pattern can repeat. And you can have from at least this many up to at least this many. Or I can leave off that means it has to start with at least n and as many more as you want. Or if you say I have to have exactly 5 of these specific things, then you can put 5 inside of the curly braces. Escape sequences, you can make them lowercase, uppercase. And then there's character classes. I can do \W that says that matches A through Z, capital A through Z, 0 through 9, or underscore. Or \W is the inverse. So that matches anything which is not a word character. \S is for a space character, which can be a space or a tab. And in certain contexts, it could be a new line or line feed. D is for a digit, 0 through 9, or capital D is for the inverse. Now, if you can use back references, now the old style is to use \1, \2, \3. You use that now, and Perl is going to complain about it. And again, I'm not sure why it messes up the formatting here, but please ignore the asterisks here. So what happens is, if I do a match and I put parentheses around parts of my pattern, then what happens is, okay, it's going to take this variable line. It's going to look for, at the anchor to the beginning, a bunch of word characters. So letters, numbers, whatever, and then a space, and then some numbers, and then an optional space. You say 0 or more spaces. And then here I have another one that says this is a word, but I have a question mark here. Question mark means 0 or 1. That means this is optional. So I can have a word, a number, and then maybe I have some spaces and another word, or that may not exist. So what Perl does is it will store into $1, $2, $3 these capture buffers. So it starts with 1, 2, and 3. So the optional one, if that doesn't exist, it will be an empty string. And let's say I have a list of names that are last name, comma, first name. And let's say there's no, hyphens or apostrophes or multiple names. That it's very basic, one name, comma, another name. Then I can reverse that in this format. But normal people's names, there's going to be a lot of variations. There's going to be more than just these word characters. So that would have to be a little bit more complicated. So this does a substitution, the S operator, and so I've bound it to this variable. And so what this does is it will look at this variable. If it's in this format, if it matches, then it will replace it with $2 space $1. So basically it just reverses that, takes out the comma, and reassigns it to the same variable. And so that variable gets overwritten if it matches that pattern. Now here is a common construction. What you have here inside parentheses, I have a variable, say, does this match this? Okay, I'm going to assume that it matches. And when it does match, then it's going to have these capture buffer 1 and 2. And so I put all of this inside parentheses, and then I can assign this to an array on the left-hand side. So I could have an array variable here, or I could just have a list of scalars. So this will take the first match, put it in F name, and this will take the second match and put it in LN. All right, now let's put all of this together and go through an example, a more complicated example. I'm going to use this IO file, and I'm going to show you where to find this. This is under in the Perl doc man page. If you look under modules, let me see. Okay, these are standard modules that should be available on a standard Perl install. There's many more libraries which may or may not be available on our systems. If you have some specialized libraries that you need, let us know. We may be able to put those into a module and make them available to your group. But for the IO file, you have the declaration at the beginning, and this says use this library. And in Perl, you'll have the parent class and then the child class separated by double colons. So this says within the IO domain, I'm going to work with this library that's specifically for files. This will create a new object. Okay, so this is a new construction in Perl. This creates an object, and this object is going to be this type IO file. And so what I can do with that is I can say, I can use this to open up, and there's a few different formats for how to do this. For example, here, I just created an object that's uninitialized, and then I used open, and then I read from that file. But I could also use, when I first create the object, I can initialize it there. So there's some variation, some flexibility there on what I can do. And then what I do is, as I open the file, I'm going to read from it, and that line that I read in, I'm just going to print it straight out to the screen. So I open the file, I print it, and then what it does is that reads one line, and then it's going to close it. So what this construction does here is it opens a file called FILE, it reads a line, prints it, and then it closes. And so if there's a problem, it'll print an error message, but otherwise it's just gonna work as you expect. Okay, now here what I do is I open it and I say, okay, make sure that it's defined. So defined will test this variable since it is an object. And if there was some kind of problem when I tried to open this file for writing, then one of the ways that Perl will handle that is it will make this an undefined value in this variable. So if I test it to see that it's defined, then I can work with it. But let's say that file existed and it's not, or I have no permission or something like that, then it will try to open it, but it will fail. And then if I test it first, then I know, okay, I can't write to that file because it's not available for writing. There's multiple ways to do it. You can put the operator inside the string, or you can separate them and things like that. And you can also work with the file modes. So here, I have an example where I'm going to open up, I'm going to use this for opening a file. The file that I want to open is /etc password. And of course, the modern Unix, that does not actually have passwords in it. It just has the list of users and their, ID numbers and their home directories and shells and so forth. So what I'm going to do is I'm going to open this file for reading. And this is going to go to this password table. And this is a scalar variable, and it's going to contain an object of this type. Once I've opened that up, I can read from it. I also want to work with the PS command. So here, this should actually be, I'm sorry, this should be a dash instead of that letter H. So here I can open up, here I use the object, and here I just use the basic open function. And then I'm gonna give it a scalar variable as my file handle. And then I'm gonna execute this command, and I wanna read the output from that command. Then I'm gonna create, as I'm gonna read from the password table, I'm gonna go through line by line. Each time through, I read one line from password table. And I notice I don't specify a variable name here. So what Perl does is it uses the implicit variable, the $_. Now the implicit variable is also used by split. So if I don't specify the name of the variable, it uses that implicit variable. So this is kind of a shorthand way. Normally I wouldn't do that because it's a little confusing for people to do that. But if you're reading somebody else's code, you can come along and you can see things like this where you have implicit variables, and it can get a little confusing, but just so you're familiar with it. So every time through, I'm going to read that password file. And if I look at password, it's just a colon separated list of fields, and the first name is the login name, and this would be the password, but it's empty, and then the ID numbers and their real name, and then their home directory and their shell. So what I'm doing is I want to know, okay, I want to map from the login name to the, so let me see, so it will map my login name to my actual name, and then my home directory and shell. And then I also have the ID numbers, the Unix ID. Okay, so what I do is I look at those fields, and if the field number is not greater than 100, then it's a system, that like 0, 1, 2, that's the system daemon. It's not a real person, so I'm going to ignore that. And then next, that's within the scope of this loop. And so what that does is it says, all right, I'm just going to ignore every input until I find something that has a Unix ID of greater than 1,000. Then I'm working with a real person. Okay, and I look at fields 2, which is 0, 1, 2, and that's the Unix ID. And then I'm going to map from the login name to the real name, which is field 4, 0, 1, 2, 3, 4. Okay, so from this field to this field. So for every person, I'm going to map their login name to their real name. So then I've read in the password table. I've stored the mapping into this hash table. Next, I'm going to scan through the output of PS. And every time through, I'm going to look for the name of the login, which is the first word on that line. And I'm going to ignore everything else. I just want to count the number of processes. So I'm going to look at the login name. I'm going to match it. I do a match to, and remember, I'm using the implicit variable here. So if I have a match symbol here, that's implicitly attached to the default variable. So whatever line that I've read in from the PS command, I'm going to match it to see if it matches a word at the beginning. If it does, that's getting stored in this variable here, login. Now, I check to see, does this exist in the real name table. And here I only assign something if it's a person, with a UID over 1,000. Otherwise, it's not assigned. So if you have like $root, that won't exist within this hash table. So if it doesn't exist, then it just skips that and goes to the next iteration. So as long as it's a real person, then I'm going to count the number of processes for that user. I first check to see, I've already seen a process from that one user. Well, this is being handled in the num processes hash table. If it exists, that means that that number is, that key, it already exists in that table. If it doesn't, so I say unless, then I have to initialize it to 0. So that I know that no matter what, either I've seen it before or I initialize it to 0, and then I increment it by 1. So every time through, if it's a real person in the password table, then I just count one more for every process that they have. And then finally, when I want to print out the number of processes which are being owned by each user, here I'm going to use the for each construct. So each time through, I have this key for numprocs. This is the table that I created dynamically, where I only matched the real names who are running processes. And for each one of those, you're going to print out how many processes for that particular login name. And then in parentheses, I'm going to have the person's real name. So if I run this here, this should say, okay, I have 6 processes being run by me. Apparently nobody else is on this particular system. So, okay, and unfortunately, I don't have time to cover this last part, references. But if you go to the class page for Perl, there are materials from previous classes, and there is an extended Perl class, which is several days, has a lot more slides in it. That was not done in Jupyter Notebook. You can do it. You can go through the slides here. There's an intermediate class that we had a few years ago where we included Perl and Bash and Python, and you can get a look at those. But I highly recommend, as you're learning, to go through the PerlDoc website, perldoc.perl.org. It has great reference materials. Next, this starting Friday, we're going to have classes on Python. So look for that soon on our homepage or on our short course list. They're not listed here yet, but they will soon be listed here. And then you'll be able to register for Python, and that's only for in person. But then we have a number of other programs, or we have a number of other classes. We're going to have a class on Clara Parabrick, which is a NGS bioinformatics software. That will be next Tuesday. We will have a class on metagenomics, which is also the bioinformatics, and then a class on Julia on the 21st, and then RNA sequencing and differential expressions on the 28th. And all of these last ones, the ones that are not Python, these will be through Zoom and available to access users as well. And then the following Tuesday in April, on the 4th, we were going to have fundamentals of R programming. So please come back to our short courses page. Starting tomorrow probably, and we will have those courses listed, and you can register for those. And if anybody has any questions, please let me know. Oh yes, also we upload most of our short courses that we record off of Zoom, we upload those to our YouTube page. And you can go there, you can see past courses, more recent courses and so forth, and also some more helpful tips on how to do certain things on our website and our clusters. So if anybody has any questions, please let me know. Thank you very much for attending, and have a good day.